Fable 5. The Industry Pushback. The security community has moved from complaining to organizing. FreeFable.org published an open letter to Commerce Secretary Lutnick and National Cyber Director Cairncross, demanding the Fable 5 export controls be lifted and replaced with an open, scientific, and transparent process for future AI risk assessments. The signatories: former CSOs, CISO-level practitioners, professors of law and cybersecurity, and AI governance advisors from institutions including Harvard's Berkman Klein Center, the Center for Democracy and Technology, and Cleveland State Cybersecurity Program, are not fringe voices. They represent the professional class that builds and breaks defenses for a living, and their core argument is blunt. The research that triggered the federal action focused on determining whether a human-prompted section of code was insecure, a capability that is a prerequisite for writing secure code, not an offensive weapon. The letter makes 3 factual claims worth stress testing. First, that the same capabilities can be replicated on GPT-5.5, Opus, Sonnet, and even Chinese models like Kimi 2.7, meaning the export control punishes one vendor for a capability class that is now table stakes. Second, that Chinese open-weight models are only months behind the best American models, and that the PRC government likely has access to unpublished capabilities beyond those. Third, that Anthropic is already addressing the research findings, making the ban a response to a problem the vendor was already remediating. The rhetorical question underlying all of it: if defenders lose access to the best tools while adversaries retain equivalent capabilities, who actually benefits? The backstory adds context to the signatories' frustration. The federal response was reportedly triggered not by a sophisticated jailbreak, but by a researcher prompting Fable 5 with a routine, "Fix this code," request that surfaced a vulnerability. Exactly the kind of workflow every security team runs daily. The gap between what triggered the panic and the severity of the government's response. Disabling the model for all customers within 90 minutes of a White House ultimatum is the detail that keeps this story from fading. Export controls designed for dual-use physical goods are being applied to models whose most dangerous capability is also their most useful one, and the security professionals who depend on that capability are now formally objecting. Supply chains under siege. The Miasma worm hit Microsoft's own Azure repositories this week, triggering GitHub's automated security system to flag and disable 73 Microsoft-related package repositories in just over a minute, more than 40 tied directly to Azure. The infection vector traces back to the Durabletask package, previously compromised in May, which strongly suggests that credentials stolen in the original attack were never properly revoked. Any build process depending on those packages broke immediately. For a package that logged 400,000 monthly downloads, the blast radius is substantial. The same weekly security roundup documents a cascade of adjacent threats: OpenSSL's high-severity use after free bug in PKCS7 handling, Nightmare Eclipse returning with the Rogue Planet exploit, Windows Defender race condition for a system-level shell, and Grade XML BitLocker bypass via offline scans, a FreeBSD page cache bug following the Linux copy fail/dirty pipe pattern, and, most consequentially for the ecosystem, npm 12's decision to block automatic execution of install scripts. That last change addresses the single largest propagation mechanism for supply chain worms: pre-install, install, and post-install hooks that run arbitrary commands as the build user. It will not stop all malicious packages, but it removes the highway the worms were using. Perhaps the most darkly amusing finding: researchers reverse engineering the mini Shai-Hulud worm discovered it uses AI prompt injection to hide from automated analysis. The payload file contains comment blocks referencing biological and nuclear weapons, topics that cause many AI models to refuse further processing. The worm is exploiting the same overzealous guardrails that security professionals have been criticizing in a completely different context. When malware developers weaponize your safety features as evasion techniques, the irony writes itself. Against this backdrop, Chainguard launched Athena, an industry coalition for coordinated defense of open-source software. The premise is simple: AI models can now find chain zero-day vulnerabilities at machine speed. The window between discovery and exploitation has collapsed from years to hours, and fragmented patch-it-yourself responses cannot keep up. Athena pools vetted pre-disclosure findings from members, rebuilds affected projects as hardened versions available before public disclosure, and coordinates platform-level mitigations. Network rules, detection signatures, traffic blocks, so that organizations without security teams still get protection. More than 24 organizations have joined, with the first wave of coordinated disclosures scheduled within a month. The question is whether the coalition model can scale faster than the worms. The Miasma family has been propagating across NPM, PyPI, VS Code extensions, and GitHub actions simultaneously. Athena addresses the vulnerability side, but the credential theft to worm propagation cycle requires a different kind of intervention entirely. On the governance side, researchers from Old Dominion University, Deloitte, Accenture, and the University of Colombo published AI Trust OS, proposing a continuous, telemetry-driven governance framework that replaces periodic manual audits with always-on zero-trust compliance monitoring. The core contribution is a shadow AI discovery mechanism, an agent that continuously scans Langsmith and Datadog telemetry streams to detect AI systems that engineering teams deployed without formal security review. In their evaluation, it identified an undeclared fine-tuned production model with no documented training provenance, risk classification, or accountable owner. Exactly the governance gap that regulators under ISO 42001 and the EU AI Act are trying to close. The paper's strongest insight is reframing compliance from filling out forms to machines collecting evidence. Whether enterprises actually adopt telemetry-first governance before their next audit is a different matter. The GPU Lunchbox War. AMD CEO Lisa Su walked onto a stage, held a box the size of a thick paperback in one hand, and ran a 235 billion parameter model live. No data center, no cloud, no rented GPU. The Ryzen AI Max plus 395, the chip inside AMD's new compact AI development system, is the first x86 silicon where CPU and GPU share the same 128 GB of unified memory. Under Linux, the GPU gets access to 110 GB of that pool, more than 3 times what an RTX 5090 offers, in a chassis you can carry with one hand. The benchmark that drew attention: this chip beat an RTX 5080 by more than 3x on DeepSeek R1 inference. The economic argument is straightforward. A heavy AI user paying for Claude Code Max, ChatGPT Pro, Cursor, and Gemini subscriptions spends roughly $5,280 annually, a $1,499 box, though the AMD website lists the full configuration at $3,999. Running Llama with a local model eliminates per-request costs, token meters, and data leaving the machine. The real advantage is not cost savings but memory capacity. Running 235B parameter models that simply cannot fit on consumer GPUs at any price. NVIDIA's moat has always been as much about CUDA and the software ecosystem as raw silicon, and AMD's ROCm stack still has rough edges. But for inference workloads where memory is the bottleneck, unified memory changes the math. Meanwhile, Apple Silicon is getting its own inference breakthrough. A developer ported AXL3 quantization to run natively on Apple hardware, achieving 2,700 tokens/second prefill and 68.5 tokens/second decode on an M5 Max. EXL3. XLMAV3's quantization format was previously CUDA only, locking out the growing population of developers running local models on Mac hardware. The port brings Metal/MLX class performance to a quantization format optimized for VRAM efficiency, narrowing the gap between NVIDIA and Apple for local inference. The infrastructure to actually use all this hardware is maturing too. One developer documented a home lab AI platform built around OpenCode Web UI with Git access, where the AI pushes changes to feature branches. The human reviews PRs, and GitOps handles deployment. The key design constraint: the AI has internet access and Git access, but cannot reach the actual services it is changing. Unreviewed code never gets deployed. The pattern: AI writes, human reviews, automation deploys, is becoming the standard for anyone running AI-assisted operations on their own infrastructure. AI at work. Turmoil, bot-sitting, and the junior pipeline. Inside Meta's new applied AI unit, an employee interrupted a company-wide livestream with an expletive-filled outburst, calling it being the company's bitch, according to a recording heard by Wired. The presenter covered their face. The incident reflects deeper dysfunction. Applied AI, a 600-person unit formed in March to support AI researchers, has become a dumping ground where engineers describe themselves as draftees, doing work they call mechanical and not creative. Generating coding puzzles to test model performance. It's literally the gulag, one employee told Wired. Most people find the work soul-crushing, said another. The turmoil extends beyond applied AI. Over 1,600 Meta employees signed a petition against a new program to monitor their clicks and keystrokes for AI training data. Instagram's chief product officer, Chris Cox, acknowledged the brutal environment on a company-wide call, comparing the past few months to running a marathon in the middle of a hailstorm. Zuckerberg's internal memo acknowledged mistakes, promised no more mass layoffs this year, and suggested applied AI was a waypoint, not a destination. Cold comfort for engineers who were told to join or leave. The 50-to-1 manager ratio in some parts of the unit tells you everything about how much individual attention anyone is getting. Meta is the most visible example of a broader pattern. A new Glean report, produced with researchers from Notre Dame, Stanford, and UC Berkeley, found that white-collar workers spend an average of 6.4 hours per week bot-sitting AI, feeding it context, checking outputs, debugging mistakes, and cleaning up errors. That is nearly a full working day every week spent supervising tools that were supposed to save time. The data point that should alarm every executive: workers who spend a disproportionate share of their AI time bot-sitting are 73% more likely to be actively job hunting. Workers who absorb it without recognition or reward grow exhausted. Then they grow resentful. Then they start polishing their resumes, the report warns. The organizations seeing actual gains are not the ones deploying more AI. They are the ones investing in the work around AI, setting context, defining what good looks like, and deciding what should never have been handed to a model in the first place. Running directly counter to the cut headcount and automate impulse is an Amazon director's argument for doubling down on junior hires. Jody Biggs makes a structural case. Every senior engineer was once a junior hire who learned by doing, and cutting the entry ramp eliminates the future supply of the senior talent every organization needs. The adoption data is interesting. AI tool pickup follows a U-shaped curve where new employees and senior staff adopt quickly while mid-career professionals struggle most. Biggs' org now does all backfill hiring at the entry level, targeting roughly a quarter of engineers being junior to maintain a self-sustaining pipeline. The thesis is that AI changes what juniors do: less mechanical production, more judgment development, not whether you need them. Benchmarks expose the agent gap. Google Research published the strong evidence that LLM-generated models can match human expert-curated forecasting systems. Their empirical research assistance era system, an LLM-guided Monte Carlo tree search that autonomously generates, evaluates, and refines Python forecasting code, produced ensembles that matched or outperformed the gold standard CDC hub ensembles across influenza, C, O, V, I, D1, 9, and RSV during the entire 2025 to 2026 U.S. respiratory season. This was fully prospective. 142 unique model prompts, over 207,500 candidate models generated, 54 selected for an internal hub, and weekly submissions with auditable timestamps on GitHub. The Google SAI Fluence ensemble ranked first among 43 eligible Flucite submissions. For C, O, V, I, D1, 9, first among 12. For RSV, a cold start scenario with limited historical data, first among 4. The methodological diversity is the key detail. ERA did not find one best algorithm and hammer it into submission. It generated models spanning mechanistic compartmental formulations, classical autoregressive methods, random forests, neural networks, and hybrid approaches. Then ensembled the best performers. The diversity of machine-generated approaches, not any single model's brilliance, is what drives the ensemble's competitive edge. The practical implication is significant. Public health systems that currently depend on dozens of expert teams maintaining individual models could achieve equivalent forecasting quality through automated model discovery, enabling deployment at scales that human labor cannot reach, particularly in countries that lack established forecasting hubs. The results contrast sharply with a new UC Berkeley-led benchmark called Agents Last Exam ALE, where frontier models scored below 25% on real-world tasks spanning more than 50 industries. OpenAI's GPT-5.5 led at 24%. Anthropic's Fable 5 followed at 22%, with Gemini, DeepSeek, and Grok all below 16%. The tasks were drawn from actual professional work across domains from audio processing to theoretical physics, contributed by over 300 industry experts. Stanford PhD student Benjamin Liu's concern is not the pass rate itself, but the failure mode. They often produce an answer that looks completely plausible but is subtly wrong. And in science, a confident wrong answer is more dangerous than no answer. The coherence problem gets a dedicated measurement tool with Vending Bench, a simulated environment where LLM agents must operate a vending machine over extended horizons exceeding 20 million tokens per run. The tasks are individually trivial. Manage inventory, place orders, set prices, collect cash. But collectively, they stress an LLM's capacity for sustained decision-making. Claude 3.5 Sonnet led with a mean net worth of $2,218 and outsold the human baseline, but even top models sometimes sold 0 items across entire runs, highlighting extreme variance. All models eventually stagnated. The failures did not correlate with context window limits, suggesting breakdowns stem from something more fundamental than memory constraints. The gap between what LLMs can do in a single turn and what they sustain over time remains the field's central unsolved problem. A reality that shows up whether you measure it with disease forecasts, professional exams, or simulated vending machines. Open weights under pressure. The Fable 5 export controls and the broader trend of model restrictions are accelerating a parallel infrastructure, takedown resilient distribution. Heretic Grimoire 1.4 represents the community's answer to platform-level model removals. A system that reduces model backups to 9 KB reproducible manifests distributed via IPFS, allowing anyone to reconstruct a model from its manifest even if the original hosting is removed. The architecture borrows from BitTorrent's resilience playbook. No single point of failure, no single entity to serve a takedown notice. It is a direct response to a world where model access can be revoked overnight by government order. The licensing landscape is shifting beneath the OpenWeights community's feet as well. A poll from ZAI found that MIT-licensed OpenWeights are losing ground, a data point that challenges the assumption that permissive licensing is the default future. DeepSeek's MIT licensed R1 model put pressure on every competitor to match its terms, but the polling data suggests the industry is moving in the opposite direction. More restrictive licenses, more usage conditions, more strings attached. The community is splitting into factions. Those who consider permissive licensing sufficient, and those who view decentralized hosting as the only guarantee that matters when a single phone call can disable a model globally. The meta-harness era. If the GPU Lunchbox War is about who owns the silicon, the meta-harness race is about who controls the orchestration layer above it. Databricks open-sourced Omni Agent, a meta-harness that orchestrates multiple AI coding assistants. Claude Code for implementation, Codex for review, local models via Llama for experimentation, in a single session with shared history, policies, and guardrails. The tool ships with example orchestrators that delegate tasks across coding agents, monitor completion, and handle handoffs automatically. Custom guardrails are defined in Python. Human-in-the-loop approval for dangerous operations like force pushes, autonomous execution for everything else. The thesis behind meta-harnesses is that no single model or provider should own an entire AI coding workflow. The harness matters as much as, or more than, the model. Fable 5's sudden disappearance proved the point. Developers relying on a single provider woke up to a blank screen. The meta-harness pattern hedges that risk by making the orchestration layer provider agnostic. Databricks CTO is reportedly dogfooding Omni Agent for everyday engineering internally, and the framework supports collaboration across devices and teams via a web UI, a feature most coding agents still lack. The economic argument underneath all of this got a detailed treatment in a video analysis of whether AI constitutes a bubble. The core thesis, asking, is AI a bubble, is the wrong question. The right question is which parts of the build-out are speculative froth and which are infrastructure for demand that already exists. OpenAI's revenue went from $2 billion in 2023 to over $20 billion in 2025. Anthropic grew even faster. NVIDIA's data center business did $194 billion in fiscal 2026. But the transformative shift is inference, not training. Agents that loop, call tools, write code, check results, and burn millions of tokens per run. A single agent workflow can consume thousands of times the inference cost of a chat conversation. The build-out is real. The question is who captures value when tokens get cheaper. A companion analysis explores how the AI investment landscape is sorting into winners and commodity providers as the market matures. On the tooling side, the market is bifurcating between maximalist orchestrators and minimalist, opinionated frameworks. StandardAgent's Aero.js is a tiny, type-safe reactive UI runtime built specifically for coding agents. Template literals, direct DOM updates, minimal API surface. It includes SSR, hydration, and a Q, UI, C, KJ, S/WASM-backed sandbox for executing code off the host realm. The bet is that agents understand JavaScript primitives better than complex framework abstractions. At the other end of the spectrum, Archex provides local-first, deterministic code context extraction for AI agents with no API key and no telemetry. Apache 2.0 licensed, designed for developers who want their code context computed locally and reproducibly. And Ironsmith takes the agent build software pattern to its logical conclusion. An open-source macOS app that creates other macOS apps from natural language prompts, working entirely with local models.